This is problem 11 on the Manipulating Vectors with Trigonometry worksheet. We have a block sliding down the plane. There are three forces on it. The frictional force, back up the plane, the normal force, perpendicular to the plane, and gravity is straight down. Frictional force is 5 newtons, gravitational force is 15 newtons, normal force is 12 newtons, angle of the incline is 36.9 degrees. What is the net force on the block? You have to give the magnitude and direction. It must be along the plane. The block is not hopping off the plane or going through the plane. If it's accelerating, it's going to be accelerating. It's going to be slowing down, which means it's accelerating up the plane, or speeding up, which means it's going down the plane. It's convenient, but not necessary, to define the x-axis along the plane and the y-axis perpendicular to the plane, like this. There's x, there's y. With this choice of coordinate system, the acceleration in the y direction is 0, which means the net force in the y direction is 0. That's very convenient. The acceleration is pure x, so we know there can't be a net force in the y direction. In addition, as a bonus, Fn is pure y, and frictional force is pure x. So the only force we have to break into its x and y components is the gravitational force. So let's do that. Plane is inclined at 36.9 degrees. We can get this angle. It's 90 minus that, which is 53.1, right here. So now the cosine of 53.1 times Fg, that's the adjacent side, that's the gravitational force down the plane. Gravity is what's pulling the block down the plane. And we need that component. Fg cosine 53.1. And in the y direction, it's down. Fg sine 53.1, which is right there. The values of the forces given. Fg is 15 newtons. So we can calculate in the x direction, and I'm calling that positive. To the left is positive. You don't like that? Don't be a baby. I'm calling that positive. Fg in the y direction is 12 newtons down. As a reminder, the frictional force was 5, normal force was 12. We just determined the gravitational force is 12 newtons along the negative x, 9 newtons down the plane. So let's stop calling them Fn, Fr, and Fg. Let's just put the values in, and we're going to put the components in. There it is. How could you go wrong with that? There's no net force in the y direction. 12 newtons up, 12 newtons down. And then up and down is along the y-axis. In the x direction, it's plus 4. I got 9 newtons down the plane and 5 newtons up the plane. That's 4 newtons. So that's the answer. Net force is 4 newtons down the plane. The block is speeding up. It's a piece of cake. Once you choose your axes judiciously, you draw a good diagram, and you calculate the components. Once you have this diagram, it's hard to mess it up.